What's up, everybody? My name is Eric. Welcome to my channel, Eric the Tutor. Today, we're going to be talking about pyruvate dehydrogenase complex. Now, where does pyruvate dehydrogenase complex even come about? Why do we talk about it? What kind of context? Well, if we talk about glycolysis, what's some of our products of glycolysis? Well, we can get 2 NADHs, we can also get 2 ATPs, and 2 pyruvate molecules. Now, the ATP can be used up readily and immediately. The NADH can be sent to the Krebs cycle in the electron transport chain to give us more energy. What about the pyruvate? Well, we can break the pyruvate down further. So our goal here is to break pyruvate down into some other molecule. What do you think it's going to be broken down to? It's going to be broken down into something called acetyl-CoA. Now, what do these look like? Well, this pyruvate has a structure that looks like this. And our acetyl-CoA has a structure that looks like just like this, okay? So we went from a 3-carbon molecule to a 2-carbon molecule. Now, the way we can do that is through this enzyme called pyruvate dehydrogenase complex. Within that enzyme, there are different components. We have a lot of cofactors, and we have 3 different regions known as E1, E2, and E3 that are utilizing these different cofactors. Some of these cofactors include lipoate, FAD, Mg2+, and we also introduce some NAD+, and some coenzyme A with a sulfur group with an SH. And we're going to get out a CO2 and our acetyl-CoA. All right, let's go ahead and jump into this and see what's going on here, okay? So if we have our cell, let's go ahead and draw our cell here. So here's our cell. Within our cell, we have our mitochondrial matrix. We're going to have some pyruvate, and the pyruvate needs to get from our 3 carbons into the cell. We need to get into the mitochondrial matrix. So the way we do that is through a cofactor here called TPP. TPP is going to take 2 of these carbons. 2 of these carbon molecules from our pyruvate. So that means we lose a CO2. There we lose a CO2. Let's go ahead and show the next step. Now we can regenerate our TPP, and the way we do that is through one of our other cofactors known as lipoate. So here is, and here's also TPP. Here is lipoate. Lipoate looks like, here's a lysine with 1, 2, 3, 4, 5 carbons. Here's our sulfur group. Just like this, we see a little disulfide bridge there. Now, what happens when these 2 carbons are going to come onto our lipoate here? Well, we're going to have 1, 2, 3, 4, 1, 2, 3, 4, carbon number 5. Here's my sulfur group. Here's my SH. Now we notice that one of these becomes an SH. And the other one, we see that this disulfide bridge here broke. Becomes an SH, and this contains our 2 carbons. Okay, there's our 2 carbons from the pyruvate that we broke down much earlier. And again, we're trying to create acetyl-CoA. So in this step, we can actually add, this would be a good place to add our coenzyme A. Coenzyme A, SH. If we react that with this molecule here, that molecule here, okay, then we're going to get our acetyl-CoA. We're going to get our 2 carbons with sulfur group and a CoA coming off of it. Now this is this structure right up here. So these two carbons are the carbons that I've been referring to with a smiley face. Okay, so we generated our acetyl-CoA. So we should just stop here, right? We're all done. We got the product we wanted. Well, let's go ahead and carry out the rest of the mechanism to see how we can regenerate our lipoate so we can get back into this state with a disulfide bridge so we can keep this going. Because if we stopped here, then we're not going to be able to regenerate this process again. So what happens when we gave up these two carbons from this sulfur and we introduced this SH in here? Well, this lysine now has 1, 2, 3, 4, carbon number 5. Here's our SH, 1, 2, 3, and another SH, okay? So now our lysine looks like this, right? We have two sulfurs that are reduced. They have two hydrogens on them. And we need to get into this state here. So how are we going to get back to here? Well, if we introduce something called FAD. FAD is another one of our cofactors. FAD can take each of these hydrogens to become reduced to become FADH2. FADH2, as we know, is rich in electron density. This can get sent to the electron transport chain if we go ahead and give some of these electrons to NAD. NADH plus H. Okay, so now this can go off to the electron transport chain. All right, and doing this mechanism, we regenerate our lipoate. Okay, here is our lipoate being changed one step at a time. All right, so that's the process. We formed our acetyl-CoA, so that was one of our main products here. We got what we were hoping for. We got our acetyl-CoA, and now our acetyl-CoA can go off and do whatever it needs to do. It can go into the Krebs cycle and go to fatty acid metabolism, and we regenerated our cofactors here. The last thing I wanted to say was this is all one large complex. So here, this is our E1. This is known as pyruvate dehydrogenase. And then down here, this was our E2. And here with FAD was our E3. Okay? And all of this was part of our, go ahead and put it over here. All of these three, E1, E2, E3, E1 through E3 equals pyruvate dehydrogenase complex. And that's everything, guys. So thanks for tuning in. We'll see you next time.